Recording has started.
Test, Test.
Ausgezeichnet, jetzt funktioniert es wieder. Okay, super. Vielen lieben Dank. Dankeschön, tschüss.
Hello, everyone. Could I ask that you please take your seats so that we can begin the next session? Yes, we're almost there to the end of the day, folks, but we have one fairly tight session ahead of us yet, and so it's important that we try to get started as close to on time as we can. My name is Craig Larley. I work in the GEO Secretariat as the Work Program Coordinator these days, which principally means that I support the GEO Program Board in their work as the body in GEO that's primarily responsible for the work program. In this session, we're going to hear from a selection of GEO Work Program activities, initiatives, and flagships about their data and information needs and challenges. So this is really a follow-on session to the one that we just heard that's looking at GEO's activities from the perspective of the engagement priorities. Here we're going to take what might be a slightly more detailed look into the work of individual flagships and initiatives in the GEO Work Program, the kinds of issues that they've had with information and data, and perhaps a little bit on what they've been working on, some of the solutions that they're developing. I'll introduce the speakers as we go through. So I'm going to start here with Leticia Navarro. Leticia is the Executive Secretary of the GEO Biodiversity Observation Network, or GEOBON, and she works at the German Center for Integrative Biodiversity Research, also known as IDIV. And she's going to talk about her work in GEOBON. Leticia.
Thank you, Craig, and I wanted to thank the GEO Secretariat for the invitation. Good afternoon, everyone. So indeed, I will speak about what are the data and information needs, but also the challenges that are faced by one of the GEO flagship, which is GEOBON, whose main objective is to monitor biodiversity change. But I wanted to start by putting things a little bit into context, and I'm sure I'm not going to surprise anyone in this room if I tell you that biodiversity is undergoing a crisis. And in fact, the level of degradation that has been observed in some ecosystems and the observed decline in population of wild species has even led some to question if we had reached a sixth mass extinction. There are, however, some good news, so to speak, and those are illustrated by a number of multilateral environmental agreements that have been signed in the past decades, such as the Convention on Biological Diversity, the CBD, and that shows some important commitment for biodiversity. Typically, those agreements are accompanied by a set of targets or goals that are there to guide effective conservation and that are designed at the global and at the national level. Concretely, what this means then is that for countries to be able to assess whether they're on track to achieve those conservation targets, there is an increasing demand for relevant, timely, and accessible biodiversity data. And this is also true if you think at a subnational level with, for instance, environmental impact assessment or the designation of protected areas. The problem with this increased demand for biodiversity data is that it's much easier said than done. And the reason is that when it comes to biodiversity, we're still facing many knowledge gaps. The first type of gaps are the spatial gaps. So if you can see this map, what it shows you, the blue dots, which might unfortunately not appear very blue at this scale, are the location of the data points that are used to calculate the Living Planet Index. This is a widely used index in biodiversity conservation that tells a story about the changes in the size of population of wild species. And you can see that the distribution of the data points is global, but it's not optimal. What is even more concerning is, still looking at those maps, you can see areas in orange. Those are areas that are projected to be converted from natural habitat to agriculture in the coming decade. And the reason why you can see those areas on the maps is because we do not have biodiversity data, at least to calculate the Living Planet Index in those locations. So not only do we not know so much about biodiversity, but we also happen to know even less in areas where we know that the pressure is going to increase in the coming years. We're also facing a lot of temporal gaps, and it's quite difficult for us to get our hands on good time series that would predate the 1960s or the 1970s, for instance. And finally, there's also important taxonomic gaps. This map here shows you the distribution of sampling points that are used to assess soil biodiversity, so soil bacteria, macrofauna, and fungi. And you can also see, again, the distribution of those sampling points is far from being optimal. So when you have, on the one hand, an increased demand from countries and regions for biodiversity data, and on the other hand, all those challenges that are just listed, you'll understand why GEOBON is needed. GEOBON is the GEO Biodiversity Observation Network. So as I mentioned, we're one of the flagships of GEO, and our mission is to improve the acquisition, the coordination, and the delivery of biodiversity observations and related ecosystem services to a wide range of users, from the scientific community to decision makers. Ultimately, our vision is to build a globally coordinated biodiversity observation network that could contribute to effective management policies for biodiversity and ecosystem services globally. We're a global partnership. We have at the moment a little over 650 members that are registered on our platform. Those are from 81 countries and over 460 institutions. So the logos that you see here are just a subsample of our partner organizations. The participation in GEOBON is volunteer-based. We have at the moment 8 working groups, 8 observation networks, and 4 task forces that are supported by a small secretariat hosted by the German Center for Integrative Biodiversity Research, or IDIF. We're based in Leipzig, Germany. And as you already guessed, our activities revolve around biodiversity monitoring. So we achieve those activities. We organize them around 3 axes. So the first one is the development of the essential biodiversity variables. The second one is the development of biodiversity observation networks. And finally, we want also all those activities to some extent to produce policy relevant outputs. And while I'm going to walk you through those activities, I use this logo of a cogwheel to represent areas which are, in my opinion, particularly relevant for the topic of this session, which is data information and information needs and challenges. And I'll start with the development of the essential biodiversity variables. So if you're not familiar with them, they're largely inspired by the essential climate variables. And we define those EBVs as a minimum set of information that are complementary to one another and that can capture major dimensions of biodiversity change. So in other words, this means that those EBVs should be biological and policy relevant. They have to be sensitive to change. They are biological state variables. To the best extent possible, they should be generalizable across realms, so terrestrial, freshwater, and marine. And they also have to be scalable and, of course, feasible. And we organize those EBVs around 6 classes that cover all the levels of organization of biodiversity. So from genetic composition to species population, species traits, community composition, ecosystem structure, and finally, ecosystem function. Another way to understand those EBVs is to see them as the level of integration between primary observations and indicators. So those primary observations are in situ observations that are collected, for instance, with field surveys or by citizen scientists, but it can also be remote sensing observations. You then integrate them, and with the help of biodiversity model, you can compute and produce the EBV data products. You can then, again, integrate those EBVs within reporting units that can be an ecoregion, can be a country or a protected area. And when you integrate those EBVs, you can produce biodiversity change indicators. Those indicators are the ones that are used, for instance, by the national governments for their reporting to the Convention on Biological Diversity, the CBD, but they can also be used in assessments such as the assessment that are being produced by IPBES, the Intergovernmental Panel on Biodiversity and Ecosystem Services. And you can easily imagine how powerful it would be if the workflows to produce those EBVs and then those indicators were on the cloud, as was mentioned this morning. Now, to deliver those EBVs and those information to our users, we are in the process of developing a data portal, so an EBV data portal that has two components. One of them that you can see on the front is the EBV catalog, which is still in development. And on that front, our data task force is working on the standards and the minimum set of information that needs to be informed on the EBV products. But we also have a visualizer, that is what you can see on the background, where there's already a couple of data sets that are already online. And you can also choose on this visualizer a country and plots. On the ground, you could plot trends for the EBV that you have chosen. Now, moving on to our second set of core activities, which is the development of biodiversity observation networks. We also call those BONs, and their mission is to contribute to the collection and the analysis of biodiversity observations. They're also tasked, of course, with developing integrated and interoperable biodiversity monitoring programs, and to some extent to work also on the data standards. So within GeoBon, those bonds are organized at three different levels. We have three national bonds in China, France, and Colombia. We have two regional bonds, the AP bond, which is the Asia-Pacific bond, and the Arctic bond. And we have three thematic bond, the M bond, which is the marine bond, the freshwater bond, and more recently we endorsed a soil bond. And of course, this doesn't mean that those are the only monitoring system for biodiversity out there, but those are the ones that went through a formal process of endorsement that has been put in place by GeoBon. Now, to support countries or regions that will want to develop their bonds, we put together a bond development process that has 4 phases: engagement, assessment, design, implementation. It's been applied already in the Arctic and is being applied now in Colombia. I do not want to get into details. I just wanted to highlight the assessment phase because this is a crucial one. This is the phase where we are going to first assess what are the needs of our users, but also importantly, because we do not want to reinvent the wheel, this is the phase where we're going to assess what is already there, what is already being done in the country or the region. So we're going to proceed to an inventory of data, tools, and platforms. And to further support countries that want to develop their biodiversity observation network, we also develop Bond in a Box, which is an online platform where users can find tools that have been vetted by the GeoBon community that go from monitoring protocols to data management tools and data analysis tools. However, I have to say that this is a catalog, so we are not hosting those tools. We do not have at the moment the capacity to host those tools on the platform. And so I'll finish this presentation by illustrating why this is all relevant and how this can help us to produce policy-relevant outputs. And indeed, very early on, as soon as the essential biodiversity variables were conceptualized, there was an effort that was made to understand to which extent they could help to track progress towards the conservation targets of the CBD. So those are called the Aichi targets. And the EBVs were found to be relevant to track progress towards 13 of the 20 Aichi targets that are part of this biodiversity framework. More concretely, for the past couple of years, GeoBon and partners have been developing a set of indicators that are derived from EBVs and that integrate in situ data and remote sensing observations, and that in the medium term are meant to be almost real-time indicators. And those are more specifically targeted towards 5 of those 20 Aichi targets. Those indicators have been endorsed by the CBD, and they are currently, some of them are being used in the global assessment of IPBES, which is going to be approved next week at the IPBES plenary in Paris. More recently, we've also been looking into the mapping of the EBV classes to the different SDGs. So, of course, EBVs will be relevant for SDG 14, life below water, and SDG 15, life on Earth. But there's also a relevance of the EBVs for other SDGs, such as zero hunger and climate action, for instance. More concretely, our MBOM has been working with OBIS, which is the Ocean Biogeographic Information System, to produce an indicator, a prototype indicator that would integrate Earth observation, data from OBIS, and local surveys, so for SDG 14. And I'm going to go quickly on the last example because I actually chose SDG 3, which is health, and I realize now this example will maybe have some relevance for the Sendai framework as well, to further illustrate the importance of biodiversity monitoring. So for this, I chose the example of the Nipah virus, which is a virus that is carried by frugivorous bats, then transmitted to livestock, and finally to humans. Some years ago, there was a really interesting publication that came out where they used scenarios of climate change to model where the population of the bats, the vector of the disease, were likely to be found, considering those scenarios of climate change. So what is important is if you look at this map at the areas in red, these are areas where the bat was not present at the time of the study and is likely to be found considering those scenarios of climate change. And these are also areas where you're likely to have emergence of the disease. Now, if you want to be able to do this kind of exercise, that means you need to have very good underlying information on the distribution of the vector of the disease. And this is an EBV. This is the species distribution EBV. And you could also see that those models could even be more improved if we start adding more information, more essential biodiversity variables, some from the species trait class, for instance, or ecosystem structure if you consider the extent of wetland or the extent of forest. And so I hope that with this final example, I was able to illustrate, well, on the one hand, what are the challenges with biodiversity monitoring, but also what is the potential and the relevance of monitoring. Thank you.
Thank you very much, Letitia. I'd like to turn now to Antje Hesseltjen from the who's one of the co-chairs of the GEO Land Degradation Neutrality Initiative, or GEO-LDN, to talk about this initiative, which is a relatively recent addition to the GEO work program.
Thank you, Craig. Just waiting for the slides to come. I'm holding this presentation on behalf of the whole GEO-LDN initiative. You see the names of the three co-chairs here on the slide, which is besides me. It's Neil Sims from CSIRO and Amos Kaboba, who is sitting over there. And we also have the working group leads there. We have Alex Wolev, who is sitting there, and we have Fabian Löw sitting there. And then we have Bill Sontag there, who is the sort of godfather of this initiative, and Doug Kripe, who is the Secretariat support of the initiative. And we have Sasha Alexander and Baron Orr from the UNCCD, who also contribute to the presentation. Since not all of you will be familiar with what LDN is, I will spend 2-3 slides on a background, so we're all on the same page. Land degradation, why does it matter at all? I would like to start with a quote from Wangari Maathai, the late environmental activist and Minister for Environment in Kenya, who was the Nobel Peace Prize winner. When resources are degraded, we start competing for them. So one way to promote peace is to promote sustainable management and equitable distribution of resources. So this is why land degradation matters. We see a lot of figures there. So around 30% of the total land mass is affected by declining soil productivity. Over 10 million hectares of arable land worldwide are degraded every year, which is an area roughly 1/3 of the size of Germany. So we acknowledge that land and soil degradation is a global problem, but it has not been high on the political agenda, especially if you compare it with its direct consequences for livelihoods and rural areas. So land degradation continues to be perceived as a local problem of local land users and not as a global problem, as a global environmental and development challenge, which is unlike the climate change, biodiversity, forests, or water. This was seen as a problem, and efforts came in place to raise the profile of land and soils in the international agenda. So now we have SDG 15.3 included in the Agenda 2030, which says that by 2030, combat desertification and restore degraded land and soil, including land affected by desertification, drought, and floods, and strive to achieve a land degradation neutral world. The custodian agency of this SDG is the UNCCD, the UN Convention to Combat Desertification, and the UNCCD Secretariat is part of this GEO-LDN initiative, so the custodian agency is directly in the initiative. So LDN, or Land Degradation Neutrality, short LDN, is now firmly established as a global overarching target to fight land and soil degradation. If you want to compare it to climate change, LDN is to climate change what the 2-degree target is to climate change. What exactly is LDN? The vision of LDN, if you look at the red target there, is keeping land in balance. So in order to ensure food security, healthy ecosystems, and human well-being. In order to achieve this, we want to maintain land-based natural capital and ecosystem services that flow from it for each land type. We have different mechanisms for achieving this. We cannot always avoid land degradation, so keeping land in balance and counterbalancing future land degradation, anticipate future losses through planned measures is one of the important parts of LDN. So LDN involves integrated land use planning to anticipate where future degradation will take place and make sure that we have an optimal mix of intervention across the landscape to achieve neutrality. The concept, this all comes from the scientific conceptual framework by the UNCCD, or the Science Policy Interface of the UNCCD. So we have the response hierarchy, which is guiding decisions on land use, actually. So it's say prevention is better than cure. So always try to avoid land degradation, but that's not always possible. We have to build infrastructure. We need to expand agricultural lands. So if you cannot avoid, you reduce, and if you cannot reduce, you have to rehabilitate degraded lands elsewhere. Where does Earth observation come in? So we have the monitoring is one big part of it. It's designed to tell us how well we are doing with LDN. So mid-course corrections can be done, and it's used for land use and management planning. LDN is in the SDG framework. We have one indicator, which is the proportion of the land degraded over total land area, and this is calculated by 3 sub-indicators, which are land cover change, land productivity, and soil organic carbon. So all of these 3 indicators are informed by space-based information and in situ, of course, but all include space-based as well. They are all now, if you're referring to Bob's presentation, if you remember, they are all considered being tier 2 indicators now. One important side note on data here is that countries are requested to use national official data sources if possible, but often data availability is not that good in countries, so then they can use global data sources. So why would we measure LDN? It's one where we just said to report on SDG 15.3 and to prepare national UNCCD reports. But the even more important thing is that we want to achieve better or more sustainable land use worldwide. We want to have less degradation, a more healthy land to provide ecosystem services. So geospatial information can support planning and decision-making processes for LDN implementation. And this is sometimes forgotten when we talk about SDG monitoring, then we're just thinking about the indicators and how to write our reports. But what we want is we want to achieve the SDGs, right? So we need to use the data that are being generated to support planning and decision-making processes. The title of the session is Data and Information Needs. So looking from a user side, who is the users? Who are we talking about? So whose needs are they? And you will not be surprised when I say that different users face different information needs and challenges. So there is not the users. In the case for LDN, for example, you can think of different actors, so that national reporting officers for international agreements. So, for example, national statistical offices or national focal points of the different conventions, they have different needs than national policymakers. So, for example, the Ministry of Environment or Development and Planning. Or these are, again, different from local decision makers that are involved in territorial planning, or project managers in partner countries, or even looking at the farmers who is keen to increase yield to adapt to climate change. So all these users have to do with land degradation, face these challenges, but they have different data and information needs. So this is one of the challenges we have to deal with within this initiative, but I think also in other initiatives, that we are not talking about the user, and it's not enough to throw out a poll to the technical community and say, now we have the users involved, but we actually need to get to know the users and understand what they need. You might be familiar with the principles of digital development. There are these 9 principles. One that I like very much is the principle to reuse and improve, and I think this is what within GEO we should always do, not reinvent the wheel, as was reiterated many times before, but reuse and improve. And the other one that is really important is design with the user. So do not design for the user, but design with the user. And within the GEO LDN initiative, which is just starting, we just finalized our are finalizing our working programs for the 3 working groups. This is where we want to focus on, and where we also want to learn from all of you, how you did it in your initiatives. So the GEO LDN initiative helps national and local actors in countries to use Earth observation to achieve LDN. And it's a unique stakeholder-driven initiative with a clear policy mandate from the UNCCD. There's actually a decision on the Conference of the Parties, which is asking GEO to support UNCCD with using Earth observation for LDN. And I think it's special that we have the custodian agency within this initiative. So we have one of the global users directly in the driving the initiative, but as I said before, there are other users as well, not only on the global level, but in the countries. The initiative has 3 working groups. As I said, they're just we're just finalizing our working programs for each of the working groups. The group on capacity building, you can contact Amos Kaboba if you have more questions on this. The main task is to increase the involvement of partner countries and other organizations, develop innovative and fit-for-purpose training curricula and learning modules, and organize and implement training on the use of available tools for accessing, processing, analyzing, and interpreting data. So Working Group 2 is dealing with data quality standards and protocols. And throughout this day, I saw that other initiatives are also dealing with metadata, data quality standards. And I think this is an important point, that GEO has the potential to bring all of this together and to make sure that we're not working in silos next to each other, but that we are aware of what each of us is doing, and we want to learn and interchange with anyone who is working on this. So, So the idea is to develop minimum data quality standards to ensure consistency, coherence, and comparability of data sets supplied by various data providers in support of country efforts to monitor LDN. Minimum data quality standards refers to the different perspectives that we have. We have perspectives of the data providers and end users, and each of those have different perspective of what quality means. And for end users, quality means fit for purpose. So what is the minimum data qualities that we need to achieve a certain goal? So for my planning processes or for my reporting obligations. This will feed into the already existing good practice guidance on SDG indicator 15.3.1 monitoring. So this is a little bit similar to what we saw for the Sendai framework before, methodological and technical guidance. You can download this on the UNCCD webpage. And this good practice guidance will be updated by the new data quality standards and protocols. The idea is that we will develop a decision tree which will guide data users on when to use which data sets fit for purpose, as I said. What is important, as I said, is to have synergies with existing initiatives like CART, it's supposed to be CART 4L, or the FAO Global Soil Partnership and other GEO initiatives. The working group 3 is working on data analytics, so this is what we will hear much more about in the course of these 3 days. It's working on federated collaborative data analytics platforms. That's the objective, to develop this. The background is that many countries need improved access to data and tools to map and monitor this SDG and assist planning decisions. So we have both the monitoring and assisting the planning decisions. Cloud computing facilities can reduce data exchange volumes and improve data availability for many developing countries. And there's a proliferation of cloud data sources, but still it's still challenging to use and not specifically intended to support SDG analytics. So these are the challenges we're dealing with within this data, within this working group. The task is to review existing collaborative platforms, to identify gaps and needs, and call for projects. So that's my final slide, just a call for everyone. Let's work together. Let's see where we have synergies and avoid duplication of efforts. Land degradation is closely related to various sectors, including agriculture, forest, climate, and disaster risk reduction. And the LDN sub-indicators are relevant to other reporting processes as well. So how do we ensure inside and outside of GEO that we follow a coherent approach in capacity building, defining data quality standards, and developing federated collaborative data platforms? And how do we ensure that we talk with the data users with one coherent approach? So this is from the user side. If we are a country, that's my timer, that's my 15 minutes gone. But that's from a country perspective. It's not helpful if different initiatives come and say, this is the data platform you need to use for forest, please use this for disaster risk reduction, this for LDN, but we need to work together and not confuse users. Thank you very much.
Thank you very much, Antje. I just will give a reminder here that we'll be taking questions at the end of this session because we do have quite a few presentations to get through. But please use Slido. If you think of a question now during one of the talks, please enter it into Slido, and we'll be tracking it and calling on some of those questions a bit later. I'll now introduce Julia Wagaman from the European Center for Medium Range Weather Forecasting. She's going to talk about streamflow forecasting, the GEO Global Water Sustainability Initiative, or GEO GLOWS, and an exciting new partnership with ECMWF. Thank you.
Thank you, Craig. So I am from the European Center for Meteorology and Weather Forecasts, and I give the presentation on the GeoGLOS partnership, which ECMWF is a partner of, on behalf of the entire GeoGLOS partnership today. And I'm try to present you some of the challenges we have to disseminate and access global streamflow data, and how the GeoGLOS initiative is working towards solving these challenges. So we live in a world which where 90% of the natural disasters are water related, and 4 out of 10 people are affected by water scarcity. And a lot of elements of the hydrological cycle are still not fully understood, and it is very complex because it involves many processes from the atmosphere, from the land surface, the river network, and also floodplains. And it's to understand and also to simulate the water cycle and the hydrological cycle. It's challenging scientifically, and this challenge is also amplified by the magnitude of the data volume we need to simulate and model streamflow data, and also the computational resources we need, and also human resources to interpret the data. So for now, the most relevant information we have on river streamflow data are in situ information, which are very critical, and they capture the natural flow data, and also man-made or influenced by man-made control systems flows. And this is still the gold standard, but to have in situ information and on a global scale, it's expensive to obtain and also to manage. Also in situ, the measurements and the equipments, it's fragile and it's prone to vandalism, and it's often that data is not widely shared due to technological, policy, and also cultural barriers. And so, we face at the moment a lack of information, and the lack of information leads to uninformed decisions. And us as decision makers, experts, and also policy drivers, it's actually our responsibility to find better solutions. And understanding the hydrological system in many ways is still incomplete, and the overall vision is more to set up a web-based application system to share the flow or stream flow information globally, and so that national hydrological organizations, they can more focus on application needs and decision applications to address water challenges in their respective countries. And I skipped this slide. And the Global Streamflow Forecast services and the GeoGLOS initiative and partnership is a real paradigm shift from how how the data, like the streamflow data, were traditionally disseminated. Before the GeoGLOS initiative, each individual hydrological organization needed a own infrastructure, being able to access the global data, to maybe download them. Then they needed to have their own resources to model the forecast data in order to provide the data for their specific application needs. And now the new vision and paradigm that comes in with GeoGLOS is to bring it to coordinate efforts, and rather to share infrastructure and capacities to give a direct access to the streamflow data on a global level with web-based application services, for example, and then national water organization can easily, they have already an easy access to the data and can more focus their resources on interpreting the data and really to bring the data and the information to the decision makers. And in these, like to bring these efforts together. So the one idea is also to bring the hydrometeorological expertise together to combine the modeling efforts and to bring and to ensure high quality streamflow forecast data on a global level. But of course, like this paradigm shifts, they always come with challenges. It's not that like it can be implemented like today and everything is fine. And it is very important to know these challenges and also to already think once the services are built up, how these challenges can be addressed. And for GeoGloves, there are like 4 different challenges, and they where the partnership tries to address them and puts more effort in. And one is, of course, large volumes of data, different data sources, also to ensure a stable infrastructure to have, to forecast the data and to process the data. And then, each forecast produced and the data has to be made available, and it has to be easily made available that people can or users can have access to it. And one way is to have web applications and web services, but at the same time, it's important that users know what they can do with these data and what they cannot do with the data. So communication, also how the data can be interpreted is very crucial here. And then adoption is also very important, like that users are trained how to use these services, how the data can be used. And at the same time, GeoGloves as a global partnership initiatives also requires collaboration with local water institutes to also better understand the users' needs and to develop the services together with users. And then we still talk about model data, so it's not in situ observation. So the 4th very important challenge at the moment is we have to focus also more to provide together with the streamflow data on uncertainty and also verification, so that people also understand how good is the forecast. And this is at the moment done by producing reforecasts, because not in situ data is not available globally for each river point on global scale. And so at the moment we provide reforecasts, and in a second step the GeoGloves partnership aims to together with the forecast data to provide verification data and validation data as part of the web services and web application systems. One example of a streamflow forecast service is the Global Flood Awareness System, which is co-developed by ECMWF and the European Commission's Joint Research Center. And it's the global flood warning system of the Copernicus Emergency Management System. And it's basically a web service where users have access to flood events for flood forecast data for the next 30 days, and also on flood seasonal outlooks up to 12 weeks in advance. And it's a data portal. Users can access it. They have on-demand access and to the data, and can have a direct access to the data. But of course, like it's like global, as with many global systems, it provides access to global data, but only for the major or larger rivers globally. And this is actually, and as one example, how GLOFAS is in action and how it can be helpful was during or right after Cyclone Idai hit Mozambique and Malawi. The DFID, the UK government development organization, requested emergency reports in order to help relief efforts on the ground. And the reports, they were requested on the 20th of March in the afternoon, and by midday at 21st of March, like one day after, like not even one day, the first report was already distributed and disseminated. And the reports were like expert interpretation of how the floods might evolve in the next days. And also an estimate how the population, how many people are might be affected by the floods in the next days. But yeah, so as we said, like the GLOFAS provides global data on only the major rivers, and now one of the GEOGLOF's visions is that to provide the same information but on a local scale. So like to downscale the global data and to provide or to channel them through local and national river networks. And yes, and there's like there was an effort with by Brigham Young University and ESRI. It was motivated by the efforts done by NOAA. They set up a national water model in 2015, and they showed that it is possible to downscale the data on a global level, to channel it through through a national or local river network, and to provide the data more on a local scale. And this is the vision, basically, to set up a tool where for each point or river point globally, one can access the streamflow data on a local scale. And this is this is just a short overview how it might work. So basically, ECMWF provides the global streamflow forecasts, and they are then brought to the data service from the Brigham University or the Severe project, and they downscale the data and provide flood forecasting data on a national level, and then on a different server there's a web application hosted which can be accessed by users, and the users can choose what information they're specifically interested in. So motivated by the example NOAA and the Brigham University and ESRI set up based on the US in 2015, there are many pilot services now across different countries, especially also based on the Severe project. ICIMOD was very interested in applying the example also on Bangladesh and Nepal and other countries because especially these countries, they don't have any resources to set up their own capacities to model flood forecasts, and so they really benefit from a web application where they have easy access to the data, and they can really focus on their water challenges in their respective country. And in the next vision or the next step is now, of course, going from the pilot projects to really scale it up, to provide a global service for local stream flow information to provide for every river point in the world local stream flow information. And the World Bank funds currently a 2-year project to provide resources and capacities to set up this service and to provide the data as a quasi-operational service by mid-2020. And the service will be hosted and run by, at ECMWF. And yeah, to finish up, this is a quote from I think the director from ECMOD, where he said that he has been extremely useful to customize international knowledge for use in regional and local level context. And the GeoGloss partnership is very, okay, one hope. Is open, and so like for everyone who is interested, it would be great to join the GeoGloss partnership and also to help together to address challenges and to bring data users and data providers together in principle. More information or like the main contacts for the GeoGloss partnership is Angelica Gutierrez, who is the GeoGloss chair from NOAA, and specifically at ECMWF, it is Crystal Prutom, who leads all the initiative of GeoGloss at ECMWF. Thank you.
Thank you very much, Julia. Moving on here, we're going to switch from water to atmosphere and specifically mercury. I'll call on Sergio Cinerella to discuss the work of the GEO Global Observation System for Mercury, or GOS for M.
Thank you, Craig. What I show here is how an activity within GEO can support policy. This is the key message. So this flagship was established in principle to support the Minamata Convention, which is an international convention formally signed by parties. As most of you know, when a convention is signed and then ratified, there is a long process for its implementation, because the implementation of a convention needs an assessment on the status of something that I will show later. So this flagship was established in support of the Minamata Convention under the UN Global Partnership on Mercury Methane Transport Research. It's aimed to establish, to construct, to construct a knowledge platform. What is a knowledge platform? From our point of view, a knowledge platform is an infrastructure that can bring knowledge from data, that can extract knowledge from data. But this is oriented to assess the effectiveness of measure established by the convention. Mercury, this is the case of we are speaking. Mercury is a very complex molecule because has a long transport range when after its emission from several sources, has a very complex cycle in the atmosphere, has a complex chemical process in water. The end of the point is the human body through the food web. So we should reduce mercury pollution, having in mind that the final point is human and environment. Legacy of this flagship derives from the former work plan of GEO. In the first phase, we established a global monitoring network. I will show you a map on that, but now the flagship has more objectives that are related to integration of data, integration of in situ and satellite data, to provide comparable monitoring data, to ensure quality of data, because one of the key problems in our fields is quality of data, and to fill geographical gaps where there are key problems, like, for example, power energy, where there is no power energy, for example. I skip this one. So when we talk about a convention, we have two different compartments. One is the human domain, where we have economic activities, the so-called drivers, that, for example, emit mercury, in this case. Mercury is released in the environment, and this is the link between the human domain and the ecosystem, because we make a pressure on the environment. The environment change its state, and so there is a long-term impact that should be recovered. This is the point at which policy enters. It tries to through policy to a convention to resume to recover a state of the environment. There are several policy action can be taken, but of course they depend on the socio-economic activity. The Minamata, as we call it, this one, Minamata Knowledge Platform, was designed through 5 big compartments. The first one is data collection. We have a compartment that collects data directly from in situ instruments, but we have analysis of emissions, reports on emissions from different sources, from different industries, different economic activities, and so on. But such data are the base, is the base for models. So once we run models, we have additional data that can be considered as another output of the platform. This is the former monitoring network established through the Global Mercury Observation System. A European project now is going towards a program. The first meeting will be held in Rome in October. As you can see, there is a gap in the southern hemisphere that was more or less covered. Here we are talking of instruments that are measuring mercury in the atmosphere. But as you can see, several countries, for example, let's say Africa and East Asia, South America, are not well covered. Within this flagship, we are trying to bring together all monitoring networks. So we have not only the Global Mercury Observation System, that is the unique global mercury monitoring network, but we have also a number of regional monitoring networks. What we are doing under the flagship, we are producing metadata for all these dots you can see here. We have produced a metadata. So we have not moved data, but if someone, let's say a scientist in this case, needs data from somewhere, he knows where the data can be taken. But as I've said, we have a number of countries that do not have in situ monitoring station. So we are in the process to deliver passive samplers that do not require energy, that are simple to handle. So I skip rapidly this one, and we have a number of countries around the world that now are using these passive samples. So under the flagship, we have formalized the knowledge by preparing metadata for those networks that are not part of GMOS. We are handling metadata for model outputs and also data. Everything is transparent to the GEOS platform and is shared through the mirror site under the GEO portal. I skip because I have only a few minutes. Okay, knowledge and data use. So how we can bring knowledge to policymakers? This is an example, but we are at the end of the process. In few weeks, we will prepare everything and make it available on the website. A policymaker, but also a citizen, want to know. Want to know how much I can reduce mercury somewhere in the world on the left part of the slide up. And then we can model the deposition over the sea, over the land. So how much mercury released, for example, in Italy, let's say, arrives in the Pacific Ocean, and how much of this mercury is uptaken by fish and then humans. So this is the key question for policy. We have prepared this model, which is a predictive model, Hermes, through a number of runs. He tries to link all these things. At the end, we will put together social and economic models to generate these curves. So the best available technology, which means how much I should invest to reduce mercury in some activity with a technology, to reduce mercury of a certain amount. So these are curves that are requested by policymakers. This is a resume of the Minamata knowledge platform made by five pieces. Current and forthcoming activity, which is the international context. GOES4M is strictly related with a European project, EraPlanet, through two specific projects, iGOSP and iCube. Is related, works with eShape, a new European project that showcases health surveillance, and GOES4M is directly related with this. Support and participate to EuroGeo's action group. Participate to the ad hoc group on effectiveness evaluation of the Minamata Convention designated by the Conference of Parties. Have produced the Global Mercury Assessment 2018, which is a technical background report for the Conference of Parties. And now we are trying to bring together all parties through the GEO Secretariat to sign an agreement that we have produced. So every partner can participate to the flagship. Thank you.
Thank you very much, Sergio. Moving along here, I'll call on Stephen Greb next. He's going to speak on the water quality initiative, AquaWatch.
Thank you, Craig, and I want to thank the organizers for the invitation to come talk to you today a little bit about AquaWatch and our activities, do an abbreviated version of what we've been up to, and talk about some of the issues facing us in the future.
I'm happy to take your time, but
That's all I got. No. Where was I? So, AquaWatch. It's a community of practice, and a community of practice can mean a lot of things to a lot of people. These are some of the phrases that came out of one of our workshops, and I think I speak for our group when I say that we're all of these things, but when you boil it down, communities of practice are groups of people that share a common concern or passion and are trying to learn how to do a better job and to interact on a regular basis. Particularly some things like to solve challenging problems, generating new knowledge, exchanging of information, provide shared context. These are important things in a community. AquaWatch, our mission is to as stated here, improve the coordination, delivery, and utilization of water quality information for the benefit of society. So again, this is kind of a high-level view of who we are. Again, in this shared value context, you could say we're here to help preserve and protect water resources for humankind and for the natural world. I also want to make one point, and some of this has been brought up here before, that we can talk of data cubes and some of the issues that we're discussing with big data, cloud services, but it's somewhat abstract. But these are serious issues that are facing our globe today. We know that shortages of water and poor water quality are going to affect 1.8 billion, that's with a B, billion people by 2025, and that's 6 years off. So these are serious issues that we're trying to tackle and affect people's lives around the globe. If we drill down a little bit, the AquaWatch goal then is to develop and build a global capacity and utility of Earth observation-derived water quality, data, products, and information to support water resources management and decision makers. But now we're kind of getting at more of the application side and what we do. AquaWatch, we follow this model on the top. It goes from left to right. These 5 components, starting with the outreach and user engagement. So this is somewhat of an end-to-end where we're starting with understanding the end user needs, and then data and observations, followed by products and information, and then how do we display or share that information in terms of tech transfer, and finally advocating for increased education and capacity building and use for the decision makers. I think our discussions today and the next few days probably are centered on number 2 and number 3. AquaWatch has 5 objectives, and they're listed here. Again, they're somewhat mapped into these 5 components up above. Coincidentally, we have 5 working groups which match these 5 objectives. So we have a group of people and working group chairs which are addressing issues within these 5 objectives. So this is another way of looking at AquaWatch, another way of looking at our organizational model. Instead of this linear left to right process change, you can think of it in somewhat circular fashion, where these 5 components, the 5 smaller circles, are feeding into what we would call a water quality information service. And they're also interacting between themselves too. And AquaWatch acts as this umbrella which fosters communication, coordination, and collaboration amongst the players within AquaWatch. Last August, we met in Stirling, Scotland, and we had a joint meeting with the Global Lakes Project. And we spent a lot of time talking about kind of where we're at in the future. This was somewhat of an organizational self-reflection, if you will, and trying to help define what this water quality information service is. And originally it was more focused on building a water quality portal, if you will. And I think through those discussions and through some discussions here with the GeoSec, we've become more, we see this information service as being all of the above in terms of these 5 working groups and the objectives they have. And we can look at this not as an information service, but maybe as a water quality knowledge hub. This isn't meant as just a quick semantics term change, but I think we we as a community are trying to better understand, how we can serve and help members of our community, and how we can help them do their job better. So, following the Sterling meeting last August, these are some of the priority actions that we came up with. Some of these would fit with our discussions that we're having over the next few days. Some of these might not be quite as applicable, but I just wanted to point out, again, just to give you some sense for some of the activities that AquaWatch is involved with, and to put our data and products discussion into some context. So we're looking at things like updating the existing data product inventory. What kind of products are being generated now? What kind of products are out there, both in terms of the in situ world and in the remote sensed world? Which ones are active? Which ones are static? And doing a gap analysis, see where we're missing data, and again, looking towards the future, developing a database. Second of all, library of algorithms. I was talking with Brian Kilo about algorithms, water quality algorithms, and we are developing this review paper on this library of algorithms that, and we will have a queryable base to look at kind of who's doing what and what's hot and what's not. One important area is optical standards for optical properties of the water. In inventory of protocols, we have a lot of people taking water quality measurements, and maybe they're not consistent between different institutions, and we want to understand what those differences are, and this is quite important when we start talking about quality control, of course. We are providing support for SDG efforts and technical support. We're doing now is a training, a survey of the training needs, understanding what the community knows now and where are the gaps or where are the areas that we could help in the training world, in terms so we can expand the capacity of this field. We're interested in demonstration projects, and we have had some proposals in to do some further demonstrations. As we've seen in some of the previous talks, these websites are quite important in terms of conveying the materials and the efforts that are going on. So we are expanding our website, and we've had a quite successful webinar series, and we're continuing that over the next couple of years. So because we've been talking about data and products, and looks like the title got kind of is cut off here by it's overlaid. At any rate, I just wanted to give you a few examples of some of the systems that are out there, systems that people in our community and some of our end users are using. In the upper left is the water quality portal that was developed by EOMAP, a private company for UNESCO. This is global in scale and incorporates both Landsat and Maris, okay, and Modus products. This is somewhat of a static site. This was a one and done contract. It ended in 2016. And below that is the Coast Watch, Ocean Watch site, which is an excellent site that has water quality information derived from, I believe, Modus, VIRS, and Sentinel-3 now for chlorophyll and turbidity products. This is Paul's area and Paul's responsibility, and if you have questions, you can ask him about it. Thirdly, third one down is Copernicus. There's been a lot of buzz about the Copernicus land use or land products. There is a water quality component to it that does have particularly suspended solids and chlorophyll. This is set up for 1,000 of the largest lakes on the globe, and presents 10-year products, 10-day means. The upper right is the data cube for Copernicus. This is a relatively new project. There's not a lot of data out there yet, but this is a consortium of folks, and these are some of the top-notch folks in our field now that are putting this together. And I'm going to talk a little bit more about it in a minute. The Tiger water observation information system, which relies for the most part on Modus products and some of the past Maris products. And finally, the open data cube, some of the work Brian Kilo will talk about, and there is this turbidity or suspended solids product that's out there. So what we're seeing is as we stitch this together, we see these disparate data in product sources. We see data coming from a variety of different portals. They're using different sensors. Some are focused on different regions or areas of interest. Some are global in nature. Some include different time scales. Some are daily. Some are near real time. Some are 10-day averages. Different time segments, and what I mean by that, some were saved for Maris, so that Maris is no longer with us, so that data is essentially stagnant, or there's not new data being generated. And product processing, as we all know, these products are done with different algorithms using different say atmospheric corrections, and so some are open source, some are proprietary. That's an issue for some people also. And we have different degrees of validation. Validation is a huge issue that's being discussed now. As I was putting this talk together, it was one evening and the people had gone to bed, and I would just say, I'm going to stop and read the comics, take a break here, and open up the paper, and somewhat serendipitously, there's this cartoon from Dilbert, which is popular in the U.S., but the boss is saying, we got a contract to estimate the water temperatures all around the globe. So I'm sorry, I can't see the screen there, but says, which part of the ocean? Well, the whole ocean. Well, we can't put sensors everywhere. So they say, we'll just put out a bunch of sensors, and then we'll measure it in 1%, and then we'll estimate the other 99%. And I said, I don't know how to do that. We'll just use math, So, and Dilbert says, wouldn't it be easier or cheaper to measure nothing and just estimate the whole thing? And the boss says, well, every now and then you come up with a great idea. So I'm not saying we've gotten to that point with our validation efforts, but this is a tough issue that we need to tackle in the next few years. Okay. So these are a couple of the water quality processors that we have. The bottom one is Kalymnos, which feeds the Copernicus project. To see some sense of the processing and the effort that goes into it. The top one, again, is for this DCS for COP, or the data cube for Copernicus. This is a quite sophisticated system, and it incorporates not just the Sentinel-3, but the Landsat and Sentinel-2, and this does have a water quality validation effort, which is one of their work packages. The problem, as I said, with Kalymnos, or this system, is it's for the 1,000 lakes, that's it, and it's a 10-day product. The problem with the DCS for COP or for Copernicus is this is going to be a fee-for-service effort. So this will not be open or free for everyone. So I'm sorry, I'm getting the axe here, but I just wanted to point out that in order to get some sense for what's out there and do an inventory and to look at where the gaps are, we're actually going to bring together data from varying file formats, including grab samples, buoy data, satellite products, and we're going to put it in this Real Earth portal and overlay it just to get some sense for what our coverage is, and also to look at what are the differences between some of these products that we have out there. And so this will give us a visual display, a time series, and we can kind of scroll across data for comparison and be updated hourly. The project will start soon. Looking forward to the future, how can we expand on this idea, this concept, the AquaWatch Knowledge Hub? We have work both to do in the in situ data field. We need more data. We have areas that are unrepresented in water types across the globe. We need access to these databases for calibration and validation. In terms of the satellite imagery, more accessibility and data discovery tools. Obviously, we've had some discussion of working more in the cloud.
Hi, Stephen. I think we're going to have to cut it off there. We can pick up some of these issues in the questions. Thank you very much.
So with that, I'll quit, I guess. Thank you.
We're almost through the presentations. We've got Paul DiGiacomo, one of the co-leads from the GEO initiative Blue Planet, here to talk about their experience. I apologize for being harsh here, but if we want to get any questions in, we're going to have to try to keep the presentations to time. Thanks.
Okay, thank you, Craig. And thank you all in GEOSEC for the ability to address you. So I don't need to go into detail the importance of the ocean. I'll just limit it to two little factoids. The one we all know is 75% of the globe is the ocean. Hence, our initiative is the GEO Blue Planet initiative for focusing on science, oceans, and society. And secondly, Blue Planet is not just the ocean component of GEO, it's the oceans and coasts. This is important, as we know, because the majority of the world's population lives within 100 kilometers of the coastal zone. All right, so I'm not going to go into all this, but a little bit more detail on the GEO Blue Planet initiative. And again, I'm speaking on a much broader group. Myself, co-chair Sophie Siev, Plymouth Marine Lab, and likewise Emily Smale, executive director of the GEO Blue Planet initiative. But you can see our mission up there, and similar to what the other GEO initiatives are. But in terms of bringing together data providers and data users, and this is a very crowded field. There's different providers. There's satellite data providers, Committee for Earth Observation, CEOS agencies. There's a lot of in situ elements. We heard earlier today about GEOs, which is primarily in situ focused, but bring together them and other providers, working with the different stakeholders and users in terms of what their user needs, but ultimately to realize more societal benefits from the Earth observations as it pertains to the coasts and the oceans. You see some of what we do. Again, we lead the coastal and ocean parts of coordinate those activities within GEO. We have cross-cutting activities, thematic activities. You see at the bottom some of our thematic activities, and I'm going to focus on the first one on the left there, which is the Data Discovery, Access, and Utilization Working Group, most germane for this group, of course. And so primary challenges to overcome. Now, if I was here 5 years ago or even 10 years ago, I would be painting a much different picture for all of you and really speaking of crying about the lack of data that we have and continuity of satellite observations. It's a much different scenario right now. And if anything, there's an abundance of data and too little information. So that's really the paradigm that we're trying to change. So you see on the left there, so we have a lot of data sets, we have a lot of different data portals, but stakeholders, the users for whatever their needs are, need better resources for their data access, discovery, and use, and in particular, more information, more actionable information from those different data sets and data portals. So it's in that context, that trade space that we're working. This is just the circular version of the value chain, but how do we go from observations to data, to products, to information, to actionable knowledge for users? And you see some of that encapsulated there. So in that context, where are we focusing with GEO Blue Planet? First and foremost is to understand and codify the information needs of the different global users, understand the requirements, match those with the existing data sets, in terms of the discovery of those, the access of those, facilitating the utilization of those, but also where are the gaps, where are the needs, and addressing those, conveying those needs to the back to the EO community, to the space agencies, the data providers, et cetera. And that's where that positive feedback loop is. It's a ever iterative process. And so I say this for my day job is there's this perception sometimes that requirements are written on stone tablets come down from the top of the mountain. They do not. It's an evolving process. In many respects, it's an organic process. And so that's one thing we're trying to do is work with the users, have that positive feedback loop. And again, to change that paradigm of having less of a focus on data, not less data, but less of a focus on data and more focus on information. So for that particular working group, the data discovery, access, and utilization, you see, so we're trying to improve the discoverability, the integration of these data sets across boundaries. Part of it is the boundary between the social sciences, the economic sciences, and the natural sciences, the environmental sciences, bridging those statistics, those national statistics we spoke of earlier, census data, all the information for the SDGs, but match those up with the in situ data sets, be they from gliders and ships and moorings or HF radar, ground-based information. Likewise with the satellite data sets, the synoptic data sets that provide the global coverage for multiple sensors, physical as well as biogeochemical and biological for both the oceans and the coasts. And then from there, bringing those together with merged products, gap-filled products, merged products, analyses, using data simulation, feed these into ocean data forecasts and predictions. And then how do you do all that? So that's what I'm going to focus the rest of this presentation on, is bringing together and having that interoperability and bringing together those data sets, the collation, the integration of those. And I'm going to give some examples of the terms in red there. Oh, just the last comment. So you see, but in terms of really, this word was used before, and I think it's a key word for us to think about in the context of GEO. What's fit for purpose for the users? Not all users are created equally. Operational is a word we hear a lot. Sometimes we think of it just to mean near real time. It does not. It has a much broader definition depending on what the different user needs are, and so we're very sensitive to that. So first is that from an oceanographic perspective, be it in situ measurements, satellites, we're really entering into the golden age of operational oceanography. To reflect that, we have a symposium in June, and particularly my agency, NOAA, and working with UMETSAT, to reflect the maturity of transitioning all these different space-based ocean parameters from research and development and into sustained mature operations. And now our focus is more on the interoperability of those different measurements and how do you link the providers to the information users and ultimately to the end users. And those are some things we're going to speak about in June and in subsequent versions of this first International Operational Satellite Oceanography Symposium. But more so moving a little bit downstream is, okay, so one thing we have to realize is that users don't care about, and this pains me sometimes, particular satellite missions, be they NOAA, be they ESA, be they JAXA, be they Canadian Space Agency, whomever, they really just care about the data products and more so the information products. So whatever we can do within the context of these ocean portals to bring together those multiple data sets, physical, biological, biogeochemical, from the multiple missions. And this is this example of trying to do that, and Steve referenced this before, the NOAA Coast Watch mission, which is a contribution to GEO Blue Planet, as is Copernicus Marine Environmental Services, et cetera, et cetera. But then also, how do we compare those different data sets, satellite to satellite, satellite to in situ, satellite to modeling output, satellite to reference long-term climatologies and time series. And here's just an example of one way we're doing that in NOAA. And again, to make it easier for users to digest these data, not to have to go run around. That said, I'm not a believer in a single, one size fits all. I think there needs to be multiple portals, but they need to be interoperable and coordinated to the greatest extent possible. And that's increasingly where we're going with these subsequent slides, the evolutions of these things. Brian did a great job speaking today of data cubes. You'll have noticed, though, that most of the data cube discussion so far is really focusing on terrestrial applications, sometimes with inland waters. Something we've spoken to Brian about and doing this in the context of Blue Planet is focusing more on coastal and ocean applications, which are actually different challenges than some of the other ones. The ocean, of course, moves. Coastal processes are very dynamic. Okay, they change frequently in time and space. How do you capture those in the context of analysis-ready data and data cubes? It's a multi-dimensional problem, a hypercube in a sense. And so that's one thing that we're interested for Blue Planet, is working with CEOS and Brian and GEO, et cetera, on these analysis-ready data sets and data cubes. But even more so, and this is where the GEO is going, and Gilberto spoke of this earlier, but developing marine and coastal knowledge hubs, okay, and bringing together all the information, the research papers, the reports, the methodologies, the algorithm theoretical basis documents, the algorithms as they're up there, the in situ data sets, the satellite, the modeling output, et cetera, and with the lessons learned in terms of one-stop shop for users. And so part of it is, again, is to work with the users to allow them to do their own processing and extract their own results, but also many users want their food delivered to them. Some users want to cook their own meal. Some users, don't have time, don't have the inclination. They just want that food delivered to them. And so that's part of what we're going to address with these for Blue Planet, the marine and coastal knowledge hubs. We spoke of these topics earlier today, the importance of the cloud, so that, thousands of users aren't moving around petabytes of data. That's a waste of time. It's a waste of disk space. How do we lower the barriers for users, particularly in developing countries, but also inexperienced users who aren't necessarily familiar with the capabilities that are out there, and provide end-to-end? You'll notice one use, I say cost-effective. I didn't say free. I think that this is a discussion we have to have in the context, because Gilberto and I have discussed this, is that someone always has to pay the bill. As data provider, as an agency, we're often on the receiving end of that bill, so just to be sensitive to that. But of course, absolutely agreeing with that zero download capability and the focus. And as I mentioned, for those users who want to do the cooking, provide them with the ingredients, and here's the recipe. For others users, say, here's the meal delivered to your doorstep, wherever that might be. I want to give an example, an excellent example funded by the European Commission Horizon 2020 project, and this is for this CORESIF, Coastal Water Research Synergy Framework. This was recently ended. It ran from 2016 to 2018. I'm not going to go into all the details, but you'll see a lot of the recipes for, it's a knowledge hub. This is a coastal knowledge hub focused on research users. What you see was to upload papers, to upload algorithms, to upload data sets. You see for some of the different foci up there, using bathymetry from SAR data, looking at water quality, oil spill detection, geospatial analyses. And although they didn't call it a knowledge hub, that's exactly what this is. And for a variety of actors, both nonprofit, the private sector was involved, academia, agencies, and I encourage folks to go to that website, because it's, if you have an interest in coastal waters and research and applications. So, but building on some of the demonstration prototype efforts like that for Blue Planet, we're going to focus on some of the key activities areas. Our fisheries knowledge hub, and particularly fisheries users, I think, don't do enough to, and partly because we haven't done a good enough job bringing them the information, can really benefit from an extended leveraging of Earth observations. So you see fisheries up there. Coral reefs is another area where there's tremendous opportunities to bring together some of these disparate programs and activities up there. The data sets are very complementary and complementarity in terms of the activities, but how do we bring those together? And that's a focus of ours in a knowledge hub in terms of activities that are going on by CSRO in Australia, NOAA in the US, and many other nations and agencies, et cetera, and working towards broader utilization and interoperability. Not going to go into detail, there's a lot of words here, but for CEOS Committee for Earth Observation Satellites, there was a meeting a couple of weeks ago, several of us in the room were there, and I presented to do this coastal applications hub, but really it's a coastal knowledge hub, bring together data providers and users under the auspices of Blue Planet, revisit requirements and user needs, and have these targeted demonstration projects, and you'll see some of them up there, but to look at things like harmful algal blooms, and to look at eutrophication and flooding, other ecosystem impacts and other key areas around the world, and really focusing on that land-sea interface. And that's really what the definition of coastal in this context is, where the ocean impacts the land and vice versa. But this could be for large lakes too. And we're planning on having a workshop next year to focus on these. But again, really to bring together these different data sets, the Earth observations, the best practices together in the context of a knowledge hub. We're actively working on this right now with Blue Planet. several key partners with ESRI, several of whom are in the room, with NOAA, with UN Environment, with as a custodian agency for SDG 14.1.1 for coastal eutrophication, bring together the expertise and the data sets, the protocols, work with them to focus on coastal eutrophication, as well as marine litter. And so you see some of the details are, but really leveraging existing data products, information products that are out there, and working with ESRI and how do we demonstrate that this is how you could do this very quickly and put together in some sense a very stripped down knowledge hub. So some of the details there. And there's several other hubs and portals out there. The Norwegians are very active, use this ocean data platform. We heard discussion earlier today, IOC and some of the ocean data information system activities. So there's a lot of activities out there from an ocean observation perspective, from an ocean data perspective, but also from an ocean information perspective and the end users. And so what Blue Planet is trying to do is bring those together, the best practices, and really help GEO realize some of these activities. And this final slide here, penultimate slide, again, the user needs, information needs are on the left for all these different areas. Again, on the right, we have these global constellations of satellite assets in situ data. We have forecasts, we have prediction systems. You know, the key areas really right now in the middle is to focus on the services, the smart people that can extract the information in support of the user needs. And with that, I encourage you to visit our website, and thank you.
Thank you very much, Paul, for that. We have about just a little over 15 minutes for some questions. I've noted there have been a number of questions on Slido. So I'm going to start by drawing on a couple of those and then maybe turn to the floor if there's any questions from the floor. First of all, and this was drawn from the top question here, but I'd like to broaden it a little bit. So if I could ask each of you to respond briefly to this first question here. To what extent are you sharing the data, information, and knowledge that you work with and that you produce in your initiative through the GEOS platform now?
Completely, let me say, because all data that we collect are available through the mirror website, the mirror site of the GEO portal, including all metadata and so on.
Yeah.
So the GeoBon ABV data portal is new. There was a previous version, but we now worked in collaboration with the University of Marburg in Germany. So it's not yet feeding into GEOS, but as soon as the catalog will be ready, then it will be the data would be feeding into GEOS. That's the idea.
I would say a number of our members in the working groups or members of our community of practice are sharing data, such as the GEMS database, which is within the GEOS portal. You know, AquaWatch per se does not have a database that we're putting in GEO now.
As we are currently evolving, we don't have a database yet, so not yet. But this is something we are dealing with within Working Group 3 especially. Alex, if you want to add, you can. No.
So explicitly in the context of the GEO portal, from an oceans and coast perspective, I think it's incomplete, but it's a work in progress.
Yes, like also the streamflow data, they're not available on GEOS at the moment. GLOFAST, they work at the moment to give easier access to the data, and with the partnership at GeoGloss, they will also be part of GEOS eventually, but not yet.
Oh, thank you. I'm going to turn to another question here, but this time perhaps I'll just ask if one or two of you wish to respond to it, you can, but the others, just to move through the questions a little faster, we'll only take a couple of responses. This one I'm building on a question from Stefan Fritz, where he talks about that if countries do not have country-specific data, global products can be used. However, the problem with this is the quality. No global land cover change data are reliable enough. So I would turn this to a question to say, to what extent do you think that it's important to be able to offer benefits to the holders of in situ data in return for their sharing data? I mean, for an example of this, perhaps sharing the models that you're using with the countries so that they could be able to reuse them within their own context. Would like to respond?
I start with the data quality. I mean, we always have this trade-off between global comparability and usability for local context. In the case of the UNCCD reporting, the UNCCD was providing each of the member countries with global data sets last year on land cover, taking them from the ESA CCI data sets. So they provided yearly land cover data sets. And of course, feedback from some countries was that's not enough. Other countries are really happy to have them and they use them for their reporting purposes. So is it fit for purpose for reporting? Maybe yes, but for planning and decision making, maybe not. So it's always a trade-off for which use do you need it. And concerning in situ data, I think there's the very much work to do. In our context, this specifically refers to the soil organic carbon. I think tomorrow we will hear a presentation specifically on that by Rick.
Would anyone else on the panel like to respond?
In the case of mercury pollution, but not only in this case, collection of in situ data is useful if these data are of high quality and can be used by modelers. So what is needed by countries is not data itself, but is an analysis of data. So what I think is that is important to share analysis of data, and such analysis must be based on high quality data.
I'll turn to the floor if there are questions